Alright, so let's get started with the tutorial. First thing we're going to do is bring in a rectangle, and this is going to be the base geometry for our grid. So we'll go here to rectangle component. There are different ways we can create it, but we'll be using this one that we can change the X and Y size. So we'll be plugging in two different sizes for the X and Y. This will make it so it can be square, or it could also be a rectangular grid. So now with this X and Y size, now let's change, let's say the Y size to be 60. And let's turn this rectangle into a surface. Now I'll go here to boundary surfaces. And we can also do this creating a plane surface, but I want to use a rectangle because that way we can use the outside polyline, and we can also use this surface. Now we'll be taking this and moving it and arraying it in the X direction. We'll go here to move this surface in the X direction. And notice that when I plug in the X, it creates a copy right next to it. And if I were to do the same thing with this, so take this, tap Alt. We can also do this in the Y direction, but here we have to plug in the Y distance here. Notice that it only moves one. So what we need to do is create a series of copies of it in the X and a series of copies of them in the Y direction. So to do that, we'll go to a series component. So we'll double click here, bring in a series component. And this series component is going to let us pick the spacing for the step. The count is going to be how many, so we'll just make it 8. And now it creates more than one number, starting at 0 and stepping by 240. So the first one is 0, 240, then 480, then 720, and we can use that to create the grid. Then we have to do the same thing, but to be able to change the extents of how many we create in the Y direction, we'll copy this down. So I slide it down, tap Alt to create a copy, and then use this step as the input for the Y. Now notice that it creates a diagonal. So what we need to do is graph the input so it moves that entire grid by these numbers, using 0, 360, 720. Now we can disable the preview on the steps before. So we'll take this, bring it down here, and then hide all of this, because now we've created a grid that we can change the extents in the Y direction, change the extents in the X direction, and then also change the size of the grid. We could have also done this using a rectangular grid, but I want to show you how you can create arrays using series. And so with this, now we can get started creating the design. Let's make this a 240, this one 360, and extents 8 and 8. Next, what we'll do is pick all of the intersecting points to be able to create the columns. So what I'll do is join those together. So I'll go to brep join, and then flatten the input, because if we look at the outputs, we still have all of those grids separated. And the reason why is because this is a grafted set, which means that there are groups of 8 rows. If we flatten this, oh, that was reverse. If we flatten this input, we'll make sure that it looks at all of those as one list. And when we look at the output, it says one open brep, which is what we want, because we want to be able to pick all of the vertices and the points that creates this grid. So the way to do this is to deconstruct the brep, and then here we'll have the vertices, which is going to be how many. So we have 81 points, And those are the ones that we want to use. So use a point component that's empty, and I'll plug those in. And this will be the location of where the columns are going to go. Next, we need to create some rectangles here. We can also make them round circular columns, but I want to show you here using a rectangle component again. This time, they're going to be located at this point. When we zoom in, we'll have a rectangle created. Now we want to plug in the X size and the Y size for the rectangle. And here's a way to keep it centered. We're going to, like if we plugged in, let's say 24-inch columns in the X and 24 in the Y, notice that they're not centered. They're starting here because that's a positive number X, positive number Y. So it will not center them unless you do this. We'll start with the X direction. Use construct domain. And here we're going to do 24 positive and 24 negative. Now this is going to make it twice as big because if we make it 24 positive and 24 negative, that's going to be 48. So we need to take this 24 and divide it by 2. So when we move something from the center to both sides, we need to divide by 2. That way we have the actual number here of 24. And now we can use this domain as an X domain input, and we can now change it relative to the center point. Now the other way to do this is to create the rectangle and then move it halfway the X and Y. And that's another way to center it. But using this one, we can now take this, copy it down, and use that same input or the same output that's copied into the Y size. So this makes it so we can change the column size to differ between the X and Y. But for now, we'll keep it 24 and 24. Now we'll be creating the columns. So we'll take these, create a boundary surface at those rectangles. And now we can use those and extrude them up. So I'll take this, type in extrude. We'll bring in the extrude component. And this one is going to be, the input's going to be the surfaces that we just created at the rectangles. And the height is going to be using a direction or a vector with a direction and a magnitude. So we'll go here to 120 for the factor, the Z for the direction. And now we have this being the height of the columns. So now that we have this, I'm going to, because I wanted to show you first how to create the grid, create the columns, because from here, depending on what direction you're trying to take it, you could take a different approach. What I want to do here is pick out a core section. So if we go here and change the extents, let's see, we have, if we do these 2 in the middle or these 4 in the middle to create a core circulation, I want to be able to pick those specific surfaces. So what I'll do is I'll go here to either the exploded deconstruct brep. We can also go back to the grid that we have here, but I'm going to just go off of the deconstructed brep because what we need to do now is get the midpoint and know how these are organized. We know we have 64 of them, and they're going to be organized from 0 to 63. So the way to do this is to visually do it is bring in an area component, plug these faces in. Now we have the midpoint, and that's going to be where we bring in our point list, which will let us plug in the centroid into the points. And the size is going to be how big. So we'll go here to say 24. And this is not necessarily part of the design, but this is part of how we can visualize how the design is organized and therefore allowing us to be able to pick 27, 28, 35, and 36. So to pick those, when we have this previewed, or actually let me disable preview on this and bring in the surfaces using a surface component. Now we need to be able to pick those numbers relative to this component where they're all contained. And so parametrically, in Rhino, you would just pick those, join them, and use them. But here we need to be able to pick those specific ones using list item. The list item will let you pick any object where there's multiple ones, like this one. And by default, it's going to pick 0. So whatever index number you pick, let's say 5, this is useful because when you use a slider, we can actually cycle through them. And let's say you don't have the center points and the point list. Well, we can just use this and cycle through and be able to find exactly which one we want. But when you have the point list, we don't have to use a slider. We can just go right-click on the index, set multiple integers, or bring in a panel. And the way that I do that is quotation marks, enter. That brings in a panel. And now here we'll go to multi-line data. So we can pick 27. So I'll type this in here. Double click inside of the panel, 27, 28, 35, and 36. When we look at the numbers here, they're individually in their own list here. So what we need to do is, well, it's one list, but they are organized in this way. Now let's go to index, plug that in, and notice that it's going to pick exactly those. We can expand it, let's say do 26 and then 34 as well. And they don't have to be in order. You can just go 26 and then 34. But I do like to keep my information organized. So we'll go here to 26 and then 34. So now we've extracted just those panels from the grid, and we're going to use that as a core element for our circulation. Now, the one thing that to keep in mind is that if we expand to 9, notice that it's going to mess it up because the way the numbers are going to be different. So now let's change this one to 9. And you just have to keep that in mind. So here we have the center one selected. We'll use that to join them together. So brep join. I'll flatten the input, although I don't necessarily need to. And now using the only brep here, I'll bake it and show you that this is one joined brep, but it still has the creases, which is fine because we're going to now pick the outside edge. So we'll go here to edges or brep edges and use the brep as the input. Notice that with this component, we have the naked, interior, and the non-manifold curves. We're going to be using the naked curves, which are going to be the ones on the outside. Let's now go to a curve component. This way we can extract just the outside curve and then hide the component that has all the other aspects of that polyline or of this brep. All right, so now that we have this, we're going to be creating a set of walls. Now, We can offset it just to the outside, just to the inside, but typically this is going to be a center line, which means that we're going to offset the curve by, let's say, 12 to the outside. And then we'll copy this again. And to offset it in the opposite direction, we'll go to negative. Notice that since we're offsetting from the center, we need to divide by 2. Otherwise, we know that the columns are 24 by 24, so it's doing 12 and 12. So now we can take this 12 and divide it by 2. Here's the other thing. This curve from the BREP is not joined, so that's something that we need to do here is I like to double click here when we have 2 different outputs to create a relay. Now we can join it together here. Notice that now it offsets as close polyline, which is what we need for this portion. So we can create a surface here, extrude it and subtract it from the columns, or using this technique, which is going to be subtracting. So I'll hide columns here. We're going to subtract the rectangle from these 2 polylines. So I'll go here to boundary or region difference. Region A is going to be what we keep, and B is what we subtract. So we're going to keep curves A, the outside, and subtract the column. Then we're going to do that one more time using this output as curves A and the columns as curves B. Or no, this is A and then subtract the wall as B. Now we can disable the preview on all of this. And notice that we have these really clean polylines that have been subtracted using the rectangles. And now here we'll use a boundary surface. We'll bring back the columns, which we can use, again, this component that extrudes the same amount as columns, and just copy the extrusion, keeping the height being the same for the walls, and plug this in. So we're overriding the rectangle input for this, and now it's going to be the same height for both. Notice this, that it's not symmetrical anymore. So let's add 29 and 37. And so it's pretty easy to pick any panels and create that just using this. These are going to be the columns. These are going to be the extrusions. And we can use this part and create another portion. So let me show you that. When we create a set of steps inside a Grasshopper, we can copy those steps and reuse them as long as we've kind of programmed it correctly, what we'll do is we'll take this and all of this, including this panel, and we'll copy it. Well, actually, we don't need those points and the point list. We can take this, copy it down here, and we've basically recreated that set of steps. But what we'll do is I'll disable the preview on this because they're overlapping. And now let's say I want to create another portion here, 50, 51, 52, and 53. Now I can change this one to 50, 51, 52, and 53. And it will create those walls with the same steps extruded and subtracted from the columns. And we'll do that again from 10, 11, 12, and 13. Now, when the wires start overlapping because we're sharing height, we can go to wire display hidden. And this will kind of clean it up a little bit here. Now we can also bring this down here, bring all of this down here to kind of keep it organized in the sense that all of the selected portions are going to be just copied down here. I'll take this, copy it again. This is going to be 10, 11, 12, and 13. So hopefully you're seeing how we can start developing a design here using a grid, let's say for a building, then picking the exact panels you want. And by joining those together, creating a polyline, we could then offset it to create the walls and make sure that those walls are subtracted from the columns. So we have all the steps here, and then we can develop it further. So what I'll do here is take this, and I'm going to be creating an offset and turning this into one floor for a building. And then I'll show you how we can copy this up to create a multi-floor building. So before we create the offset, I want to create a set of beams and a structure that sits right on top of the columns. So let's go back to the deconstruct derep. Let's take those faces and offset them to the inside. So using the surfaces that we have, I'll use those faces, extract them using this surface component, which is empty. These will just go into this one. Then offset the curves of those surfaces to the inside. By default, with offset curve, it'll offset to the outside. So we need to bring in a negative component. And using the size of the columns right here, we can now offset halfway to the inside. And then halfway to the outside. We can also change the size of this. So if we don't want it to be tied necessarily to the columns, we can just go 24 positive, 24 negative. And using these two, we'll create a boundary surface. Since we're offsetting to both sides, we know we're going to divide this by 2. Now we can take this and move it up to where the columns are. And since we already have that here using this 240Z vector, we're just going to use that same vector and move these surfaces up in the Z direction. I'll flatten the input because here they're grafted. And now we can extrude this to create the column height or the beam height. So what I like to do is just copy this component, use this, and then lower the number. But notice that they're overlapping, so we are going to bring them together using solid union. And so here's the thing. Since they're overlapping, this number 86% means that this component is going to take 86% of the time to calculate this entire script. This is 86% of the work. So one way to avoid using solid union, especially with so many objects, is this. It's easier to subtract a two-dimensional line than a 3D Boolean union, a 3D object. So I'll delete that for now because this is what we'll do. Here's the thing. We would think that just by these overlapping, we can use region union, but they're not going to work because the overlaps are just not going to calculate. So here's a way to fix that is region union, just the ones that go to the outside. Now, when this is grafted, they're all separate, so it's not going to work unless we flatten the input. And now we can use this to subtract the inside ones. So we'll go to region difference and now subtract from A, which is what we want to keep, the outside line, subtract the inside offsets. Now this is what we can turn into a surface. Notice that this is dashed as well, so we need to flatten the input on that. Now notice that it's a little bit faster because using a two-dimensional subtraction is a lot easier. Now we have this surface at the bottom here that we moved up here. And this one now we can extrude. And it's a clean set of beams, and we can change the size here. Now notice that it does take a little bit, it lags a little bit, but it won't lag as much as joining together using Boolean union. Now from here, we know that we have the height of 36 plus 240, and that's going to be the size and the location of where I want the floor to be. So what we'll do now is using those surfaces here, using the region union, now we can use this. So some steps that we create for, let's say for the beams, we could reuse that step because we already have this outside polyline, and we can offset it to the outside using an offset curve. Now we can turn that into a surface. We can move it up. But the movement is where we're going to add the vector of 240, the vector of 36. And since we can add vectors, we can use both of these and hide the input. So there's not a bunch of wires. And use this to move it up. Why? Because even if we move up, extrude this up further, well, that's calculated because we have both of those vectors. And now we can use this to extrude a floor. If you see some distortion here on the ground, it's because we have, and we're previewing a lot of these surfaces, which are overlapping. Now we don't really need the point list unless we want to change the location of where the walls are. And so now we have a vector of the height of the column, the height of the beam, and the floor, which now we can use to create the floor array, whether you want the columns to sit on top of the floor plate, which we can change the offset, or if you wanted to sit right on top of the beam, which is typically what we would do, then we would pour the floor slab on top. So maybe let's do that. We'll take this, we'll take all of these different outputs, including the walls, and move them up. Now we're going to move it up not just once, but to create a series of them. So let me show you that. Let's go to move, and we'll do one at a time. We'll move the columns using series. Now here's the thing, series, you can't use a vector, but we know we're going to move it up. And now we can add the floor plus the beam and use that as a step. And for count, we'll keep it small at the beginning here with 3. So now we've created 3 different movements, 0, 276, and 552. And this gets plugged into the input. Now notice that we're not getting this working unless we graft the input. And then it creates the columns arrayed vertically in the Z direction. Now the cool thing about this part is we can now copy this then array the beams, copy this, and array the floor, because we're just reusing the steps. And then do the same thing with the walls, the core first, this wall, and this wall. Now we can also, rather than doing all of those separate, bring in a geometry component and plug all those into one. And just use one of these to bring them up. Now, sometimes you wouldn't want to do that because you want to keep them separate because you're going to develop them in a different way. But this is more of a overall form that we're creating. And so with this, I think you get the idea of how we can take grid and develop an entire building from it. And just by using some of the sliders here, you're seeing that we're creating a multi-floor building with walls that can also serve not just as circulation or interior, but as lateral support for a column system like this. So the last thing that I do is create the footings, but I'm not going to do that on this one. What I'll be doing is adding some color to it. I'll disable the preview on everything else before we move it up. Now we're going to take these and use a custom preview and a swatch. Create the floors here. Then I do like to hide the wire on input for the custom preview. And so we'll copy this down, do the same thing for the beams. I'm just kind of keeping it grayscale here. And when you want, let's say if we want that to be glass, we can, well, it won't work for lateral support, but we could just change the opacity. We'll make it here 100. You can kind of see into the building here. So the custom preview can be ghosted if you change the opacity. And we can change the column size or the column spacing. So if 240 by 240, let's say it's too big, we can change it 240, or 240 and 360 is too big, we can make it 240 and 240. Or 360, 60. That's going to conclude the tutorial. What I'll do here is organize this, clean it up, add some labels. I'm going to do that in a time lapse. And if you have any questions or anything, make sure to let me know in the comments below. I'll also have this available on my website to download so you can follow along and see how everything plugs in. But just want to thank you for stopping by, for checking out the tutorial. Hopefully you learned something new. I've posted different tutorials about how to create these buildings, but I think this one is a little bit of a different approach where you can actually develop it using the point list to pick the exact panels and then develop those walls and develop the rest. So thank you for being here, and I hope to see you in the next one.